All right, so we're in 3.4. 3.4 is properties of logarithms. Properties of logarithms, okay? Well, we learned about logarithms in the last section, and now we're gonna learn some properties of logarithms. So there is a product property of logarithms. I'm just gonna say logs. And they have some preconditions. They say let b, x, and y be positive real numbers where b is not 1. Well, the log property for the product says log to the base b of x, y. The log of the product is the sum of the logs, equals log to the base b of x plus log to the base b of y. Okay? That's the log property for products. The log of the product is equal to the sum of the logs of those two factors. And again, they said let b, x, and y be positive real numbers, b is not equal to 1. Okay? So how do we apply this? So example 1. Example 1 says, write the log as a sum. Write the log as a sum. And that's exactly what it does. You take the log of the product, it becomes the sum, addition of the two logs. So write the product as a sum, if possible, and simplify if possible. Okay? Then they say assume x and y are positive real numbers. Assume x and y positive real numbers. We have to do that because we remember from the last section that you can only take the log of positive quantities, right? The domain of the log function is from 0 to infinity. It has to be bigger than 0, in fact. So that's why they require x and y to be positive real numbers, okay? So A says the log to the base 2 of 8x. Log to the base 2 of 8x. Well, according to that property, this is log to the base 2 of 8 plus log to the base 2 of x. And they say simplify if possible. Well, log to the base 2 of x, but log to the base 2 of 8, I'm sorry. Well, remember how this works. The log to the base 2 of 8, if I said that was equal to some y, so if you need to, bring it over here. If you call that y, if I translate that from log form into exponential form, 2 to the y equals 8. This means, what does y have to be? 2 to what power equals 8? That's what this statement says. Well, it has to be a 3. So this is equal to 3 plus log to the base 2 of x. That's what they mean by simplify if possible. The log to the base 2 of 8 is 3, because 2 to the third power gives you 8. Again, we still got to recall that equivalency from that last section, 3.3. B says ln of 5xy. ln of 5xy. So B, ln 5xy. Well, the product rule generalizes. That's ln of 5 plus ln of x plus ln of y. Again, the log of the product is the sum of the logs. Okay? I can't simplify any of those, so that's as far as I can go. Next is the quotient rule. The quotient rule for logs. Quotient rule for logs. Same assumptions. B, x, and y are all positive. Okay? So the quotient rule for logs says log to the base b of x over y is log to the base b of x minus log to the base b of y. That's the quotient rule for logs. The log of the quotient is the difference of the logs. Okay? The log of the quotient is the difference of the logs. Okay? So example 2. Example 2. And we're on page 399, or 398 rather. Says write the log as the difference of logs and simplify if possible. Write the log as the difference of logs. Difference of logs and simplify if possible. And again, assume x and y are all positive, because you can only take the log of things that are non-negative. So they have log to the base 3 of c over d. Log to the base 3 of c over d. Well, that's the log of the quotient, so that should be log to the base 3 of c minus log to the base 3 of d. I can't simplify that anymore because I don't know what c and d are. B says log to the log of x over 1,000. B says log of x over 1,000. Log over 1,000. Well, whenever the base is missing, we said that that's the common logarithm, whenever the base is missing. So that's log to the base 10 of x over 1,000. According to that rule, this is log to the base 10 of x minus log to the base 10 of 1,000. And again, simplify if possible. We did this in the last section. I can't do anything with log to the base 10 of x. But again, log to the base 10 of 1,000. In other words, 10 to what power gives you 1,000. So that's going to be 3. Log to the base 10 of 1,000 equals 3. You can do that one in your calculator. Take your calculator, use that log x key. Take log of 1,000. Log of 1,000 is 3. Okay? So that's the quotient rule for logs. So we've got the product rule, log of the product is the sum of the logs. We've got the quotient rule. Log of the quotient is the difference of the logs. Okay? Our next rule is called the power rule. The power rule for logs. Power rule for logs. Power rule for logs. What the power rule for logs says, again, let b and x be positive numbers, b is not equal to 1. Log to the base b of x to some power is p log to the base b of x. So if I've got I'm taking a log to some base of a quantity raised to a power, that exponent comes down in front and multiplies by the log to that same base of the whatever that thing is. All right, so that's the power rule for logs. So example 3 says apply the power rule. Apply the power rule. So A, they say ln of the fifth root, ln, the fifth root of x squared. Ln of the fifth root of x squared. Well, the first thing is to rewrite that. Ln of the fifth root of x squared means x squared, or x to the 2/5 power. We talked about that before. We're converting from radical form into exponential form. The fifth root of x squared is the same thing as x to the 2/5 power. And now I can apply this rule. I can't apply this rule until I have this form. Log of something to a power. So now I've got that. Log of this thing to that power. Well, according to that rule, the power comes down, and I'll have ln of x. So there's that rule. And again, x is positive. You can only take the log of positive quantities. B, log of x squared. Log of x squared. Well, again, if you don't see the base, that's base 10. So this is the common logarithm. The log of x squared, according to that rule, is 2 times the log of x. So pretty straightforward to apply that rule. Okay? Pretty straightforward to apply that rule. Again, x has to be positive. You can only take the log of things that are greater than 0. The domain of the log function is from 0 to infinity, not including 0. It has to be bigger than 0. You can't take the log of 0 either. If you try that on your calculator, log of 0 or ln of 0 is going to give you an error. Okay? Well, and that's why they say in the next line, really importantly, so they don't have to keep saying for positive things only. So 2 stars. They say, in examples and exercises, we will assume the variable expression within the logarithms represent positive numbers. In all remaining examples, assume we are taking the log of, or positive. So that's just to make sure that we never try to take the log of something negative. So when they did this one in the book, they said, okay, 4x greater than 0. When they did this one, they said, okay, 4x greater than 0. They want to make sure we understand that we can only take the log of things that are positive. So they're just making sure that that's clear for the remaining problems. So properties of logs. Let's talk about properties of logs. Okay? We had some in the last section also. And again, they say let b, x, and y be positive. B can't be 1, so look at the conditions. I'm not going to write them, but you better look at preconditions. Okay? In fact, you better be reading your book. So property 1, the log to the base b of 1 equals 0. Property 2, they say log to the base b of b, and again, this works because you can ask yourself, b raised to what power gives you b? Better be a 1. Number 3, they say log to the base b of b to the p. Well, that better be p. Okay? Because b to the p power gives you b to the p. Number 4, they say that b to the b raised to the log base b of x power, log base b of x power, okay, equals x. So this whole thing here is the exponent on b. So b to the log base b of x equals x. Number 5, we're going to add these properties we just talked about. The product property, log to the base b of xy is log to the base b of x plus log to the base b of y. We have the quotient rule, log to the base b x over y, log to the base b of x minus, log to the base b of y. And finally, we had the power rule, log to the base b of x to the p is p log to the base b of x. So these are all my log rules. And what we're going to do, we're going to use these log rules to expand and contract expressions. We're going to use these log rules, these properties, to both expand and contract these expressions. Okay? Well, what do I mean? Well, for example, log, they say of AB over C. Okay? If I had this, so this is just a quick example. If I had log of a quotient, quotient rule says I can write this as log of the numerator minus log of the denominator. This is the log of the product, so I can rewrite that as log A plus log B minus log C. So I've used a couple of rules to expand this thing into that. That's an example of an expansion. I started off with 1 log, and I wound up with 1, 2, 3 logs. So I expanded this into that. Okay? You can read the rest. Let's do example 4. Example 4 says write the expression as the sum or difference of logs. Write the expression. And one thing I should mention, if you started out with this piece, I could reverse the process. This is equal to that according to my product rule for logs. So I can start with this, and the sum of the logs becomes the log of the product, and then the difference of the 2 logs becomes the log of the quotient. So I can start with one expression and expand it to this, or if I started out with these 3 logs, I can compress them into that. We're going to do both things before it's over. We're going to use these log rules to both expand and condense these expressions. So write the expression, they say, as the sum or difference of logarithms. As the sum or difference of logs. Okay? So wait, they give us log to the base 2, log to the base 2, z cubed over xy to the 5th. Z cubed xy to the 5th. Okay? Log to the base 2, z cubed over xy to the 5th. Well, the first thing I'm going to use is that quotient rule. So that becomes log to the base 2, z cubed, plus, minus. The quotient rule says subtract, the difference, right? Log of the quotient is the difference of logs. So log of the numerator minus log of the denominator. So I applied this quotient rule. Okay, I applied that quotient rule. Well, again, they want me to expand this as much as I can. Okay? They want me to expand this as much as I can. So I've got a couple more things I can do. Right here, I can apply my power rule. So I'll get 3 log to the base 2 of z minus, I'm going to put a parenthesis here or a bracket. I've got a log of a product, so that becomes log x plus log y to the 5th. So I use the power rule to go from here to here, and then I use the product rule on this thing. The log of the product is the sum of the logs. Now that minus sign has got to hit both of those. Okay? So 3 log to the base 2 of z. I'm going to have minus log of x. That's this thing, you won't change. Then minus log of y to the 5th. The last thing that I'll do, these don't change, but now I can use my power rule because that's an exponent. So that 5 will come down in front. And that'll be my final answer. So this is an example of starting with 1 log and writing it as the sum or difference of those 3 log terms. Okay? I started off with 1 log, and I wind up with those 3 log terms, sums and differences of those terms. Okay? All right, B. Let's do the next part of the example. All right. Part B. B says the log cube root of x plus y squared divided by 10. Cube root x plus y squared divided by 10. Okay? Well, the first thing to do is change this from radical form to exponential form. I've got a radical. The cube root is a radical. It's a radical sign. So I'm going to rewrite that as log x plus y squared over 10 to the 1/3 power. The cube root is equivalent to raising everything under that radical sign to the 1/3 power. The cube root is equivalent to all of that stuff to the 1/3 power. Now I've got the log of something to a power, so I can use the power rule to write this as 1/3 log x plus y squared over 10. That power comes down according to the power rule. Well, now I've got that power, 1/3. I'm going to not worry about that for now. I got the log of a quotient, so I'm going to use the quotient rule. So I get log x plus y squared minus log of 10. I use the quotient rule on this step. Okay, the log of the quotient is the difference of the logs. Okay, so I'm going to write this out. I'm going to go ahead and distribute the 1/3. 1/3 times this, give me that. 1/3 times that gives me minus 1/3 log of 10. Okay, now I've got the log of something raised to a power, so that power comes down. That's the power rule. So a 2 comes down, there's already a 1/3 there. 2 times 1/3 gives me 2/3 log x plus y. Minus 1/3 log of 10. Log of 10. Let's think about that for a second. Log of 10 means log to the base 10 of 10. And if you remember, that was one of your log properties. Log to the base b of b is equal to 1. All you're asking yourself is 10 raised to what power gives you 10? That's 1. Log to the base 10. And take your calculator and do it. Take log of 10. Use that log x key. Log of 10 is 1. So my final answer is that. Okay? My final answer would be that. I don't have a property of logs that does anything with the sum. I don't have a log of x plus y equals something. So I can't simplify that first term at the very bottom. Okay? All right. So, this is expanding. This is expanding. We start off with the single log, we write it as a sum or difference of logs. Start out as a single log, write it as the sum or difference of logs. So we're expanding. We're starting out with one log and expanding it. Okay? This is the expansion process. So I can use those log properties to expand expressions. Okay? Let's see. The other thing I can do is I can condense. I can start out with multiple expressions and use those log properties to condense it and write it as a single logarithm. I can do the opposite process. So that's what we're going to do now. So example 5. Example 5 says, write the expression as a single logarithm. Write expression as a single logarithm. Okay? And simplify if possible. So you always have to simplify if you can. What do I mean by and simplify if possible? Stuff like right here, the log base 10 of 10 is 1. You have to apply those rules and simplify as you go, if possible. So, they give me log to the base 2 of 560 minus log to the base 2 of 7 minus log to the base 2 of 5. Okay? Log to the base 2 of 560 minus log to the base 2 of 7 minus log to the base 2 of 5. So the first thing I'm going to do is, there's the difference of logs. So I'm going to apply my log quotient rule for logs. The log of the quotient is the difference of the logs. So this becomes log of 560 over 7. And then minus log to the base 2 of 5. Because log to the base 2 of 560 over 7 is log to the base 2 of 560 minus log to the base 2 of 7. So I'm using that property in reverse, that quotient rule for logs. Well, how many times does 7 go into 560? Well, that's just 80. Take your calculator. 560 divided by 7 is 80. Okay? So now I've got 2 logs left. But again, I've got subtraction again. So now I can apply that quotient rule one more time and get log to the base 2 of 80 divided by 5. Log to the base b of m over n is log to the base 2 of m minus log to the base 2 of n. Okay? But what is 80 divided by 5? Okay? 5 goes into 80, 16? 16? Okay? And now, can you simplify this? So, this is equivalent to asking the question, 2 raised to what power gives you 16? And the answer is 4. 2 raised to the 4th power. 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So 2 times itself 4 times gives me 8. So that problem simplifies to 4. And again, we got to here, we wrote it as a single logarithm. They said write this expression as a single logarithm, but they said and simplify if possible. So I was able to simplify that single logarithm and get the explicit answer of 4. So again, you have to simplify if possible. You won't always be able to simplify, but when you can, you have to. Okay? When you can, you are required to simplify. Example 6. Write as a single logarithm. And simplify. If possible. If possible. So I got A. A says 3 log A minus 1/2 log B. Okay? minus 1/2 log C. 3 log A minus 1/2 log B minus 1/2 log C. Okay? Well, again, there's more than one way to work these two. Okay, there's more than one way to work these. I'm going to work on these terms first. I can pull out a minus 1/2 out of both of these, and I'll have log B plus log C. Okay? And that's addition, so I can apply my product rule. The log of B times C is equal to the log of B plus the log of C. Well, now I gotta apply the power rule, because I've got 3 log of A. That becomes log of A cubed minus, I got 1/2 log of this, that becomes BC to the 1/2. Okay? All I'm doing is using my log property twice. Okay? And 1/2 power is the same thing as log of the square root, BC. I got subtraction, so the last step is to write this as log of A cubed square root of BC. That would be my final answer. Okay? Well, the log properties apply to the natural log as well. So I can say B, 1/2 ln of x. They say plus ln x squared minus 1 minus ln x plus 1. All right? All right? Well, again, the 1/2 becomes an exponent. Okay? Plus ln, this is subtraction, so I get x squared minus 1, x plus 1, find the quotient rule, right? So ln of x, this becomes ln of the square root of x, ln of this stuff. Sorry. I've got addition, so now I can apply the product rule, right? The log of the product is the sum of the logs. So the square root of x, I multiply the two, this times that stuff. And it's ln of all of this. Okay, if you want parentheses, you can have them. Now, we can simplify a little bit, I believe. X squared minus 1 is x plus 1, x minus 1. I factored x squared minus 1 and x plus x minus 1. These two things cancel. I get ln square root of x, x minus 1. So there is my expression. So these are condensing. I'm starting out with multiple logs, and I'm winding up with a single log. Sometimes you can simplify completely, but most of the time you'll just be left with a single log expression. Okay? Most of the time you'll be left with a single log expression. Okay? I'm going to let you look at example 7. I'm going to go to the change of base formula on page 402. Page 402, the change of base formula. Page 402, change of base formula. Okay? Well, it's exactly what it sounds like. Okay? We said that your calculator can only do base 10 and base E calculations, because you have a log x key, that's the base 10, the common log, and you have an ln x key, that's base E, the natural logarithm. So your calculator, if you have that recommended calculator for our class, can do base E or base 10 calculations, okay? But it can't do base 2 calculations, for example. It can't do base 7 calculations. It can't do base 3/4 calculations. Remember, a base can be anything between 0 and 1, or it can be anything bigger than 1. So the base could be 1/2, or 1/3, or 5/6. The base could be 7, it could be 11, it could be 12. So your calculator knows how to do two types of calculations, base 10 and base E. So if I asked you to, if you didn't have access to a computer program that could do any kind of base calculations, well, you could apply this change of base property and change, say, a base 2 logarithm into a base 10 logarithm, and then use your calculator. So this change of base formula is going to allow us to change from one base to another. Okay, this change of base formula is going to allow us to change from one base, whatever base we're given, into any other base we want. Okay? So what do I mean? The change of base formula says log to the base b of x. Okay, so I'm starting out with some base b. This b could be a 2. B could be a 5. I'm starting out with a base. And they say this is equal to log to the base a of x, log to the base a of b. So I'm going from base b to base a. I'm going from an expression that had base b, and I'm going to convert it into whatever base a that I want. Okay? Well, again, there's the change of base formula. And let's write it down for two specific situations. I'm going to write the change of base formula for common logs, and I'm going to write it down for natural logs. In other words, I want to start off with some base b and I want to convert to common logs. So common logs is base 10. So this rule, if this a was a base 10, I'm going from some unknown base into base 10, becomes log to the base b of x equals log of x over log of b. Okay? That's what this rule written to, if you wanted to change to base 10, would be this. This rule, if you wanted to change to base e, would say log to the base b of x is ln of x over ln of b. So all I'm doing is translating that rule into the rule to convert from any base into a common log, or the rule to convert from any base b into a natural log. Okay? Now let's see how it works. Let's do an example. So with that in mind, example 8. Example 8. They say estimate, this is A, estimate log to the base 4, they say of 153, and they tell us, okay, they say between two consecutive integers, between two consecutive integers. They want me to estimate log to the base 4 of 153 between two consecutive integers. Okay? Well, again, let's think about what this means. Log to the base 4, 153, say that equals something y. Well, again, 4 to the y would be 153, right? I'm just going from log form to exponential form using our equivalency, all right? So 4 to some power is 153. Well, we know that 4 cubed, 4 times 4 is 16, 16 times 4 is 64. And on the other side of the coin, 4 to the 4th, 64 times 4, right? Take your calculator. 64 times 4 is 256. Okay? So again, 4 to some power equals 153. So this number is, we're trying to figure out what y is such that 4 to that power gives you 153, but we know that 4 cubed gives you 64, and 4 to the 4th would give you 256. So that value y better be between what? 3 and 4. y is between 3 and 4. So y is greater than 3, but less than 4. Because 4 to some power that's bigger than 3 will be bigger than 64. 4 to some power that's less than 256, okay? Well, I said that wrong. I said 4 to some power that's bigger than 3 will be bigger than 64. 4 to some power that's less than 4 will be less than 256. Since 153 sits between 64 and 2, since 153, again, 4 cubed is 64. 4 to the 4 is 256. Since 153 sits between those two numbers, 256 and 64, since he sits between those two numbers, this value y I'm looking for better sit between the 3 and the 4. So the log to the base 4 of 153 has to be a number between 3 and 4. Log to the base 3 of 153 better be, between 3 and 4. All right, so that's the first part. That's the first part. All right. Part B. Part B. B says use the change of base form to approximate that thing by using base 10, round to 4 decimal places. So that was A. B. Use the change of base form to find log to the base 4, 153. They say using base 10, round to 4 places. Okay? So I'm going to use this. I'm going to use that. So, log to the base 4, 153. So log to the base b of x. Log to the base b of x. So the b in this case is a 4. The x in this case is a 153. Log to the base b of x. I've got log to the base 4 of 153. B is 4. X is 153. So according to this, that should be equal to log of x. So log of 153 over the log of 4. And since that's just a regular old common log, you can plug those two numbers into your calculator. You can calculate the log of 153. You can calculate the log of 4. So use that log x key on your calculator, take the log of 153, and they say this is approximately equal to 2.184691431 over 0.602. 0599913, and round that to 4 places, and they say that's 3.6287. So we use the change of base property, and we converted log base 4 into base 10 using that one, and then we could plug that stuff into our calculator and get the decimal approximation. And C says, do the same thing for base E. So do a change of base formula to find log to the base 4 of 153 using base E, round to 4 places. So I'm going to use this thing right here. So log to the base 4, 153 equals, and again, the b is a 4, the x is a 153, so ln of 153 divided by ln of 4. Take your calculator and do that. And it'll be the same type process. You can do ln of 153 on your calculator, you can do ln of 4 on your calculator. Divide those two numbers and round to 4 places, they say you'll get 3.687. Well, it's going to be the same thing, right? 6.2. Sorry. So this is how the change of base property works. We can change from a base, in this case a base 4 to base 10 or base E, and we can find these expressions that we normally would not be able to find or evaluate.